Alright everyone, today we want to simplify surds, which are square roots that don't give whole numbers. Let's look at question A, which is the square root of 180. We first need to find the biggest square number that goes into 180. We ask, is there a square number like 4, 9, 16, 25 that divides 180? Yes, 36 is a square number, and we can say that 36 times 5 would be equal to 180. So now we can write the square root of 180 is equal to the square root of 36 times 5. Now we need to split the square root based off the rule that the square root of a times b would be equal to the square root of a times the square root of b. We can apply the same rule in here and write the square root of 36 times 5 would be equal to the square root of 36 times the square root of 5. And we know that the square root of 36 is equal to 6, so we can write this as 6 times the square root of 5. And that would be our simplest form. Now let's head to question B in here, which is the square root of 63. Again, we need to find the biggest square number that goes into 63. What would be that value? It would be equal to 9. So we can write 9 times 7 would be equal to 63. And we can say that the square root of 63 would be equal to the square root of 9 times 7. And based off this rule, now we can split the square root into two square roots. So we can write this as the square root of 9 times the square root of 7. And we know that the square root of 9 is equal to 3, so we can write it as 3 times the square root of 7. Okay, now on this question, we should want to rationalize the denominator. So we had the expression 1 over the square root of 2 minus 1. We want to rationalize the denominator and prove this value would be equal to square root of 2 plus 1. In order to rationalize the denominator, we have to multiply the top and bottom by the conjugate of the denominator. So on here, our denominator would be the square root of 2 minus 1, and its conjugate would be equal to square root of 2 plus 1. So you basically just change the negative sign in here to a positive sign. And then you just multiply top and bottom by the square root of 2 plus 1. So let's say I'm gonna write the third expression again in here, which is 1 over square root of 2 minus 1. Now I'm just gonna multiply the top and bottom by square root of 2 plus 1, square root of 2 plus 1. So the top would be equal to square root of 2 plus 1, and on the bottom, it would be the difference of the squares, because we have square root of 2 minus 1 and the square root of 2 plus 1. And we know based off the formulas, if we have a minus b times a plus b, it would be equal to a squared minus b squared. And on here, our a would be equal to a square root of 2, and our b would be equal to 1. So it would be the difference of squares. So our top again would be equal to a square root of 2 plus 1. Our bottom would be equal to a square root of 2 squared minus 1 squared. And the bottom would be equal to 1, and the top would be equal to a square root of 2 plus 1, which is the value that we wanted to prove. So in here, we have more expressions to simplify. Let's look at part A. We have the square root of x squared, y squared. As you know, based off the formula that we have a square root of a times b would be equal to a square root of a times the square root of b. We can split this square root into two square roots, so we can say this one would be equal to a square root of x squared times the square root of y squared. And we know that the square root of x squared would be equal to absolute value of x, and the square root of y squared would be equal to absolute value of y. Since we don't know if y or x is positive or negative, we should leave it as it is. And we can write this as the absolute value of x times y. Now let's move to part B. We have the square root of x squared plus y squared. As you guys know, based off the formulas, the square root of a plus b is not equal to square root of a plus the square root of b. So we cannot simplify this expression more than this, and we should leave it as it is. So this one couldn't be simplified more, and it should be written as square root of x squared plus y squared. Okay, now let's simplify more expressions. Let's look at question A in here. We have the square root of x plus y to the power of 4. So we can write this as x plus y to the power of 4, all to the power of 1/2. So basically I changed the square root in here to exponent form. Based off the rule, we have a to the power of m all to the power of n would be equal to a to the power of m times n. So we can use this rule and write this as x plus y. And now I have to just multiply 4 and 1/2, which would be equal to x plus y to the power of 2. And this would be equal to x squared plus y squared plus 2xy. Now let's head to C in here. We have the square root of x to the power of 4 plus y to the power of 4. As you guys know, based off the rules, we know that the square root of a plus b is not equal to the square root of a plus the square root of b. So we cannot simplify this expression more than this, and we should leave it as it is. So on this question, we want to prove that the square root of x plus the square root of y would be equal to the square root of x plus y plus 2 times the square root of xy, which is this expression in here. And we also want to find the corresponding expression for square root of x minus the square root of y. First, we need to use the algebraic identity formulas. We know that a plus b squared would be equal to a squared plus b squared plus 2 times ab. And if we use the square root of x as a and the square root of y as b, we can rewrite this equation as the square root of x plus the square root of y squared would be equal to the first term squared plus the second term squared plus 2 times the multiplication of 2 terms, right? And based off the formulas, we know that this would value be equal to x plus y, and based off the product rule, we know this one would be equal to 2 times the square root of xy. But what we are looking for in here, we are looking to find the value of this term inside the bracket. So what we should do, we should take a square root from both sides of this equation in order to get the value of this term inside the bracket. So we're just going to take the square root of the both terms on each side of the equation. So it would be square root of x plus the square root of y squared. And this one would be equal to a square root of the terms on the right hand side, which would be equal to x plus y plus 2 times square root of xy. Now, we know that if you take a square root of a squared number, we should always use the absolute value. But since in here we are dealing with a positive number in here, since the square root of x plus the square root of y is always a positive number, we don't need to actually bring the absolute value in here, and we can just write it simply as it is. So we're just going to say that this one would be equal to square root of x plus the square root of y, and on the right hand side we have x plus y plus 2 times the square root of xy. And we could successfully prove that this expression, square root of x plus the square root of y, would be equal to this expression in here, which is the same mentioned on the question as well. Now let's proceed with the second one. In order to find the corresponding expression for square root of x minus the square root of y, we should use the identity formulas again. We know that a minus b squared would be equal to a squared plus b squared minus 2 times ab. Now in here, we're just going to use square root of x as a and a square root of y as b. And we're going to rewrite the equation now as square root of x minus the square root of y squared, which should be actually equal to x. This is the same terms that we mentioned on the previous part. So I'm just going to simply copy these terms. Since a square root of x squared is equal to x, a square root of y squared would be equal to y itself. Only in here we have a negative sign. On the previous part we had the positive sign. So we're just going to write minus 2 times the square root of xy. And as you know, we are looking for the corresponding expression for a square root of x minus a square root of y. We are not looking at the squared version. So what we should do, we should take a square root of both sides of the equation in here again. So this one would be equal to a square root of x minus square root of y squared. And we take the square root from the right hand side as well, which would be equal to x plus y minus 2 times the square root of xy. And since this value in here could be a positive number, it could be a negative number as well, we should take absolute value and we write it as a square absolute value of a square root of x minus the square root of y would be equal to x plus y minus 2 square root of xy. So in this question, we want to write each of the expressions under a single square root sign. Let's start with b. We have a square root of p times the square root of q cubed. Based off the product rules on the square roots, we know that the square root of a times b would be equal to a square root of a times the square root of b. And we can say on this question our a is equal to p and our b is equal to q cubed. So we can write this as a square root of p times q cubed. Now let's head to d, for example, which is the square root of 3 minus the square root of 2. We can't combine two square roots through subtractions under one square root. There is no rule like that the square root of a minus the square root of b would be equal to a square root of a minus b. So in other terms, we can say that a square root of a minus the square root of b is not equal to the square root of a minus b. But the question asks us to write it as a single square root expression. We can square the whole thing, then write that squared form under one square root. So based off what we learned on question number 5, we can say that a square root of 3 minus the square root of 2 is equal to square root of 3 minus square root of 2 squared. And now based off the question number 5, we know that the square root of 3 minus the square root of 2 squared would be equal to 3 plus 2 minus 2 square root of 6. So in other terms, this would be equal to 5 minus 2 times the square root of 6. And now we can just substitute this value in here and put it under the square root in here. And we can say this would be equal to square root of 5 minus 2 square root of 6. So on this question, we want to use the indices to write the following expressions without the root sign. So on A, we have the fourth root of a squared. We're going to write this as a squared to the power of 1 over 4. Based off the power rules that denote a to the power of m all to the power of n would be equal to a to the power of m times n. And on here, our m would be equal to 2, our n would be equal to 1 over 4. So we can write this as a to the power of 2 times 1 over 4, which would be equal to a to the power of 1 over 2. Now let's look at b in here. We have a square root of 3 times the square root of 5 all to the power of 3. Now what we can do is we can write this as the exponent forms. So we can write a square root of 3 as 3 to the power of 1 over 2. And we can write it as 5 to the power of 1 over 2 and all to the power of 3. Since in here we have two powers that the bases are different but the exponents are the same, we can just multiply these two powers together by just multiplying the bases. So we're just going to write 3 times 5 to the power of 1 over 2 and all to the power of 3. So we have 15 to the power of 1 over 2 and all to the power of 3. And based off the power rules that we mentioned on the previous section as well, this one would be equal to 15 to the power of 3 times 1 over 2, which would be equal to 15 to the power of 3 over 2.